Hey guys, it's Professor Avila. Just wanted to kind of go over that last example as we kind of cut it short. And I was thinking about it on the way home, and I really want to make sure that we can cover this example a little bit better. And so the example we were working with was this g of x cosine function. Let me just write it back down again. And so in class, I was talking about doing some factoring with what you had inside here, but I think that some of what I was saying might have been, getting confused. So I want to do this example over again and not factor what's happening on the inside and come up with a good plan of how to attack these problems where you have a period and a phase shift. So remember how I was doing a squish and solve, where I was taking this function that's inside the parentheses, and I was squishing that in between the normal 0 to 2 pi domain. And so when I go to solve to find my true shift, what I'm actually doing is I'm saying right now, if I start here at 0, if that's my current position, when I change the phase shift and the period, or I do that adjustment, where is the new start going to be? Well, that pretty much gives me everything I have to do for every single coordinate. So this is my original start and stop. And so if I first subtract pi over 2, then I get this new set of values. What is that? 3 pi over 2. And then when the next operation is to divide by 2, or again, multiply by a half, right, then that gives us my new starting position, which is my phase shift and the period adjustment. So when I'm moving 0 to now be at negative pi over 4, that's taking into account the shift of this pi over 2 and the period adjustment at the same time. And so my new interval of where I start and stop is going from negative pi over 4 to 3 pi over 4. It did the same thing for 2 pi. It took and made the adjustment for both the period and the phase shift to get to 3 pi over 4. So that's what I'm going to do. I want you guys, when you're attacking these problems, to look at how you would solve for the new 0, or kind of solve this for your phase shift. And I want you to apply those same two steps to all of your coordinates. So for example, when I'm looking at my x values, right, and I'm thinking about how I'm going to shift those, let's just look at what happened. So my original value was 0. Right? The first thing I did to that was subtract off the pi over 2. Right? And then after that, I multiplied by a half. Right? And so that's what I'm going to do to all of my coordinates. So my guide is going to be just that. I want you to look at this and say, first, if I were to solve for x, the first thing I would have to do is subtract off pi over 2. And then from that, I would be dividing by 2, or again, multiplying by a half. And that's what I'm going to do to adjust for every single coordinate. Right? So I'm going to now write my guide in for all of those. Right? So remember our first few coordinates. My originals are the 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are my original x's. And so now, again, the first thing I'm going to do is I'm going to subtract off the half from all of these, or sorry, the pi over 2. And then I'm going to multiply by the half, just like I did over here. And so that's going to end up giving me a negative pi over 4. This is going to be 0, pi over 4. Right? Pi over 2, and 3 pi over 4. All right, so there's a gap of a pi over 4 running through all of those. And you can see that when I did this adjustment here, I got to negative pi over 4, which is my new start. And when I did that exact same adjustment, I got to 3 pi over 4, which is my new stop. And so this, if I do this combination just like I would to when I did my little squish and solve, that's going to give me the process for finding all of these. All right. And again, then for the y values, you're just going to do 4 times your normal cosine values and then subtract 3. Right. So my normal cosine is 0, 1, or sorry, 1, 0, negative 1, 0, 1. Right. So this part is not the difficult part. This part, adjusting the y values, was pretty straightforward yesterday. It was mainly this adjustment right here that we were trying to figure out. And that's why I wanted to look at it again so we can try to get a little guide to help us out. And so those are going to be my new coordinates. And so when I'm looking at all the rest, my amplitude was 4. Again, my period is pi. My phase shift, right, if I look at how that shifted, is negative pi over 4. My midline, that's going to change to y equals negative 3. And then my domain, right, so some of these we had already put on the board. And so I'm just going to rewrite them so we have them. And I believe we were pretty much down to where we needed to graph. But my main concern was this issue right here. I don't think we talked enough about that. And since you have 4 of them for your homework, I want you to be able to have a process. Right. So let's just look at this real quick. Let's try to get a little quick graph. Right. Oops. Alright, so I'm going to label these by pi over 2s. And so I can skip every other one. That way I have a spot for my pi over 4 increments. And so I think that's pretty clear right there. And so at negative pi over 4 and 1, I'm at 0 and 0 and negative 3. And then I'm at pi over 4 and negative 7. And pi over 2 and negative 3. And 3 pi over 4 and 1. Oh, I guess I really didn't need my graph to go that super crazy. Again, this is my midline. So now I'm just going to make my graph. It's going to be kind of tight squish in here, which is fine. Just like that. All right. So when you're doing your graph, right, just make sure that you take your time to really get that that adjustment up here. All right. So again, the process. Don't worry about what we wrote on the board in terms of like where's the B value, where's the the phase shift. Look at your guide here. Again, take whatever you have inside these parentheses, squish that in between 0 and 2 pi, and the 2 steps you do to get your new domain are the exact 2-step process you're going to do for the rest of your coordinates as well. All right. If you guys have any questions, definitely come to my office hours. All right.